So these are transparent benefits of upgrading. So welcome to our talk on upgrading the database engine, as well as some of the new features in SQL Server 2005 database engine. My name is Don Vilen. I'm a program manager on the SQL Server storage engine. Been working with SQL Server at Microsoft for 10.5 years, and on SQL Server 2005 for about 4.5 years. So looking forward to have something not called 2010 as the next version. Okay, well, what I'd like to talk about in this section today is the upgrading of the database engine itself. So this is the SQL Server relational database engine that I'll be talking about. We'll hit a little bit on instances and the directory structures, some on the new resource database. A little bit about system tables and the metadata that we have for those system tables. Of course, we won't go into it as much depth as you might like. We could just sit there and go through every single system table and get you all ready for the new system table posters that everybody will have on their wall in a couple of weeks. And of course, you'll all be pros just like you have been with SQL Server 2000 and exactly what goes on inside of all of that. Then we'll also talk a little bit about backwards compatibility and also when the upgrade actually happens. Well, this next bullet is a rather impossible one. We're going to talk about the new features in the SQL Server database engine. I've got a list here of about 100 and some of those, and I don't think we'll have time to cover all of them. So what I'll do is I'll just highlight a few of them, and I know that you'll be able to get more details in a lot of the other sessions throughout the week. But what we will concentrate are some of the benefits that you'll get just by doing the upgrade. So let's say you don't do anything at all to your system. What are some of those benefits? What are some of those changes that the system's going to be doing under the covers for you? Your behavior should be very, very similar to what it has been in the past, so it's not going to break anything, but what are some of the things that we've done underneath the covers that you'll be able to make use of? So the first thing I wanted to talk about a bit is the actual instances and the directory structure that goes with it. So in the past, SQL Server had a rather interesting directory structure, something that wasn't very usable when it came time to do upgrades or install new instances, or where did those names come from, things like that. So one of the tasks for the setup team this year, or for this version, has been to come up with a way of identifying the various instances that you've got installed, having some correlation between what you find in the registry as well as what you find in the file system. And so what you'll see is that we have an instance ID assigned for each instance. An instance is a little bit broadly defined here. So in this case, an instance, although you know you can have multiple instances of a single SQL Server, and along with that instance of SQL Server is typically a SQL Server agent and perhaps a full text search, but you can have multiple instances now of analysis services. So when you install analysis services, you can install it 10, 15 times on the same server if you wanted to. Of course, it's one of those things that you typically don't want to because you have to provision it accordingly, make sure that there's enough processing power in order to handle all of the different instances you have. But you can install those, and we do test up to 16 instances at a time of the SQL Server database engine. And on the Enterprise Edition, we were actually testing up to 50 instances now. Although, with Enterprise Edition, you are now getting up into higher and higher power, more and more and larger databases. It's like you probably don't want to have more and more instances. But if you were doing some sort of consolidation, if you really did want to separate out security for various instances, it is possible to put several instances on a single box. Okay, so when you install a SQL Server and a SQL Server agent and the full text search that goes with that, those typically all go into a single instance or are considered a single instance. Your analysis service, although it might have the same name, and you might think of it as the same instance, as far as what we're talking about here, as far as the instance ID, it actually gets its own ID number. And the same thing for reporting services. And you can see this here, where the actual directory structure is called MySQL, MSQL. Okay, so we're keeping a list of these things? Okay. No, so MSQL.1, MSQL.2, and MSQL.3. So these are all under the Microsoft SQL Server directory. And you can see that there are some common objects as well. So there are some up there for 8.0, 8.0 being SQL Server 2000, and then 9.0 being SQL Server 2005. Okay, so the registry has a very similar structure to this, using the same numbers, the same instance IDs. So if you can identify which instance ID goes with a certain instance that you're interested in, then you can find all the files that go with it, as well as the registry structure. Okay, and as always, it's always fun to go in there and play and look around, see what files there are, what files are new, what files have changed. But we're not going to dive into it quite that far here. Now, another interesting thing as far as the upgrade of the database engine goes is the new thing called the resource database. So as you may be familiar with, in the past, when you did an upgrade, it could always take quite a while to run through a lot of upgrade scripts. And what we had to do when we were running those upgrade scripts, and I remember back in 7.0, and I think also in 2000, there were like 19 or 20 of these upgrade scripts that we had to do. And they would go through and they'd effectively drop all of the system stored procedures that were there in master, and then it would recreate them. So you might remember the xpstar.sql file and a few of the other ones that are out there. These are actually sets of SQL scripts that we would run to create all the system stored procedures. Well, that meant that we would lay down the new SQL Server binaries, start up the SQL Server service, and then have to go through and run all of these scripts for you. And it could take quite a little while. Back in 7.0, I was the program manager and the developer, being one person who was responsible for all the setup in SQL Server 7.0. And I had to sit there and watch those scripts a lot. So I'm very happy that we were able to get rid of these. But the way that we got rid of these is by putting all of these system stored procedures in a separate database. That database is a read-only database called the resource database. The resource database is one of those things now that when we have to do an upgrade in the future, or even this one, all we have to do is lay down this new resource database file right next to the one that was there. Of course, there wasn't one there from SQL 2000. But in the future, we'll just lay it right next to it. And then we stop and start the service, and it'll start using these stored procedures instead of those over here. And so there's no need to run all of those scripts that we've had to do in the past. So if you've been around SQL Server for quite a long time and you remember the old hourglass with the sand that was falling, well, really it was the cue that the sand was falling through, it wouldn't have taken anywhere near as long had we had this type of thing back then. Okay, so this is a read-only database. It's invisible to the users. As far as you're concerned, everything's out there in master. It's just that it sort of gets redirected to come on out of the resource database. So that means that there's no scripts to run in the when you're upgrading the system stored procedures. And so this is a directory of the data directory for this SQL Server. And you can actually see that there's an MSSQL system resource LDF and MDF. So these are just looks like a regular database to SQL Server. It's just that it doesn't appear in your regular tools. It doesn't show up as a regular database. So we've changed the system tables and the metadata inside the server. As you must be aware, we add new features every version, and each feature that we add often needs new metadata. That new metadata often means that there has to be something changed in the system tables that help describe what's going on inside the server. For example, one of the things that we've added in SQL Server 2005 is the ability to partition tables. It used to be that the table was the smallest unit of storage that we'd have out there. You create a table, put stuff in it. But now a table can be split into separate partitions. Okay? Well, somehow the metadata has to be able to support that for the tables and the indexes and everything else. Then there's other things that we needed to change as well. There's new capabilities with the SQL Server Service Broker, messages, procedures that automatically start. Where does all that metadata go? So we had to change some of the system tables, and we figured this was the best time to do a lot of the work that we really have needed to do. And so what we've done now is that we have a new whole set of system tables that are virtually invisible to you. So you don't even really know that these tables are here, except there's a lot of system catalog functions and and views that allow you to see this in a meaningful way. If you saw a lot of this stuff down at the bottom, we'd have to spend months and months telling you just how to work with that. But you're familiar with things like your sysObjects table. Well, there's still a sysObjects, but it's called sys.objects now, and it has a little bit of a different view on things, very similar to what you had in the past. There's still things for looking at tables and looking at views, but where those things are stored, it's the same way that you normalize or denormalize your database sometimes. We've had to do that same sort of thing with our system tables. And so we give you these views in order to go through and take a look at it. So the true system tables are not really directly visible to you as a user, and they're no longer directly modifiable. So in the past, there was this capability of using SP-configure in order to do an allow updates, and you could go in there and you could mess with any of the system tables you want. Then you call PSS because it doesn't work anymore, and they ask you, well, what'd you do? Oh, I didn't do anything. And, well, that sort of thing happens sometimes. But anyway, now you can no longer go in there and actually modify the system tables directly. And you say, well, what happens if I have to turn on emergency mode in a database? I always have to go in there and do this mask with a status bits for the database. Well, now there's an alter database statement that sets the appropriate configuration items. So that means that you don't have to know about bitmaps anymore. You don't have to know about bit masks to go through there and set a certain bit without clearing all the rest, because so many people did. They set the emergency mode and they cleared all the rest of their status bits inside because they just did a set rather than an OR operation. However, okay, so I've got these scripts that say allow updates in it. Are they all going to break? Well, in order to preserve backward compatibility, we've done things like, well, allow updates is still there. And you can still call SP-configure, but when you do it, it doesn't do anything. Okay? So there are a couple of SP-configure things in there. We went to extremes to make sure that your backward compatibility didn't break. And that's one of the examples. That seems a little bit odd, in fact. So that's why, well, it doesn't do anything more. But we do have all of these catalog views to give access to the system metadata. I think there's 120 or 150 different catalog views out there. And so they'll be backward compatible even in the future. So if the underlying stuff changes, we'll make changes to the appropriate catalog views so that it still appears to be the same to you. Perhaps we'll add more in order to give more functionality. Most of the system tables from SQL Server 2000 are now views on those same underlying tables. There are a few system tables like syslocks that aren't there anymore. We'd rather you use the new dynamic management views to get to locks, which has more information, more interesting information for you. As you can imagine, there must be some changes to locks because of the table partitioning thing again. If I have these partitions, instead of having table locks, maybe I'm going to have locks at a partition level, something like that. Now, the system views typically are out there in something new called the sys schema. So you may be aware of the separation of schemas and users, and using schemas in a little bit more, in more the way that conforms with the ANSI spec. Of course, we had users long before ANSI had schemas, but then now we've made sure that ours aligns with that. And so we've got these new schemas, and there's a sys schema in every database that allows you to get to some of the system information. Another big change with the system views is you can only view the objects that you have some permissions on. So this is a security enhancement. It was always one of those things. How come my least capable user can go out there and find out that I've got the who's getting fired table out there or who's getting raises table? Not that they can look in it, but they could just see that those objects existed, knowing that layoffs were coming along or whatever, just information disclosure just by knowing that the table existed. And so now you don't have that. Or, of course, your hacker who comes in and saw a certain stored procedure that says, effectively give me root, give me SA capabilities, and now all I had to do was figure out how to make that thing work. Well, now they can't even see those objects that they don't have some access on. So I mentioned that we've worked very hard on backwards compatibility. So almost all of your scripts that you have should work perfectly fine. And I say almost because there's a lot of people who actually do use non-documented procedures. Maybe you found something in a magazine somewhere or somebody's book that says, hey, go use this undocumented DBCC, use this undocumented trace flag or something like that. We haven't felt that it's too necessary to be backward compatible for all of those things. However, anything that was documented, we've done our very best to make sure that it's still backward compatible. So we work very hard to preserve backwards compatibility. There are some things that are not compatible. There's the upgrade advisor, I think you've already seen. The big thing about that is that whenever they show you the upgrade advisor, it's a database with every one of these errors in it, or every one of these things to make sure that the upgrade advisor can actually detect that there's a problem. And so my standing joke is that when we came out with SQL Server 7.0, DBCC suddenly ran 10 times faster. Everybody figured that DBCC was broken. Okay, and so we got all these bugs. It can't be working. It's too fast. Okay, well, the same thing maybe with Upgrade Advisor. It didn't show me anything. It must be broken. Well, maybe it's because you really aren't doing anything that was not documented or anything that isn't backward compatible. But Books Online does have a list of everything that's continued or discontinued, everything that's deprecated for the future, everything that might be a breaking change or anything that changes behavior in any slight way. So we've documented this. And I'm very happy for that because back in SQL Server 6.0, I was the guy who came up with that short KB article of the 3 things that worked a little different in 6.0 from 4.2, and then I added more to it and more to it and more to it, and finally we ended with like 28 items. And then I did the same thing going from 6.0 to 6.5, and it started out with 2 things and it added on. Now it's in Books Online. You don't have to go to a KB article in order to find that. And this has been testing that we've built into the product for the last couple of years, just looking at what is no longer backward compatible from the past. I did want to mention the compatibility level, again, of 8.0, 8.0 being SQL 2000. And so you can turn this on. However, be aware that it doesn't turn your SQL Server into a SQL Server 2000. It says that, oh, this syntax which has changed, if you'd use this, our syntax analyzer will still allow this old structure, or this old construct. But often what you're doing when you do that is you're limiting some of the access to the new capabilities. So make sure that you move from an 8.0 compatibility up to 9.0 compatibility as soon as you find that the upgrade advisor is saying that everything is okay and that you've tested your application out there. One thing to keep in mind is that 8.0, just like that 6.0 compatibility that is now no longer there, that 8.0 at some point will no longer be there as a compatibility level as well, and so you're going to have to address it at some time. And do you want your DBAs or your developers who know what SQL 2000 did versus 2005, would you rather have them fix it, or would you rather wait about 8 years, 10 years, and have your developers who know nothing about what's happening right about now to go back and fix it? So as much as possible, I'll give you a bit of a push to switch up to 8.0 compatibility level. Sounds like we need to be having a little more fun. When does upgrade occur? So what happens during upgrade? Okay, well, we upgrade your master during the upgrade process. So there's a part of time there. Well, when the upgrade is first going on, we have to change your master because the underlying structures within master have to change. Okay? The other databases will be completed as part of your database startup. So once master gets done, we go through your databases and we start each of them up. And when we start up a database, we take a look at the database version. The database version says, what version of the metadata do you have? And then the SQL Server says, well, I can only work with metadata at this level. And so it goes through the steps that are necessary in order to convert your database structures into whatever it is that it needs. Okay? So this is automatic at database startup. It's also automatic anytime that you take a down-level database and you attach it to an up-level server. So if you take a database that you detach from SQL Server 2000, you bring it on up, it looks at the 2 versions, the version from the file and the version of the server, and whether it can bring it on up through those steps. Usually, we can go back 2 full versions and bring that all forward, do all the steps necessary. There are some cases where you might have gotten a middle version in between in between betas or CTPs or something like that, where we don't really do an upgrade between that and between those two steps, because nobody should have that. But anything that is released to customers typically can be upgraded from one version to another. It also happens whenever a down-level database is restored. So anytime you take a database, a backup of a database, you restore it on a newer server, it'll look at the versions on those and then do the appropriate stuff. Now, what does it actually have to do? Well, it has to convert the metadata for the old table structures into the new table structures. It has to go through and notice all of these things to make sure that the metadata is now corresponds to what we need for the newest version. And then this is important. Once an upgrade is, or once a database is upgraded, you're not going to be able to move it down a level. Okay? So make sure that if you have, well, it's always just a good idea to make sure that you back things up. Perhaps do things in parallel for a while. Do your appropriate testing in order to make sure that everything within SQL Server 2005 is working as you expect. You must have some lab somewhere where you're going through some test machines where you're making sure that the most basic operations will execute the same as before. We have this great replay capability where you can capture a workload in SQL Server Trace and Profiler. Capture a workload for a week if you have the storage capacity to do that. Replay that on your SQL Server 2005 and see if the answers come out to be exactly the same to make sure that there aren't any changes or anything that happens. Okay, so let's go through some of the new features that we have in SQL Server 2005, and this is just in the database engine. Forget reporting services, integration services, notification services, analysis services. Forget all of those things for right now. They're all in the box, of course. iChart, okay? Now these are just the ones I remembered to write down. So there are quite a few others. And so rather than make you try to read this or go through it, I've extracted some of these and put them on another slide. Now, for each one of those, we could go through and do all kinds of demos, but I don't have the time to go through and do that. So I wanted to mention a few of these and at least give you just that little bit of an incentive to go off and say, oh, at least I heard about this. Now, what might that mean when it comes to going to additional sessions or learning more in Books Online? There's a lot of stuff on Books Online. We have a lot of online webcasts. So if you go out to Microsoft.com/SQL and look for webcasts, or even out to TechNet and do the same. There's a lot of webcasts. You can hear me talk for, let's see, none of these, I guess, but you can hear me talk for about 10 hours or 15 hours on webcasts on database mirroring, on the high availability, on changes specific to the storage engine, and various other things that are out there. Okay, so let's just mention a few of these things here. These are sort of rather large functions that are out there now. The SQL Server Service Broker is one that I wanted to mention. This gives us messaging and queuing capabilities inside SQL Server. You can set up conversations between two web services, for example, send information back and forth. You can have messages go into a queue. We've got some new statements called send and receive built right into SQL Server using SQL Server tables as queues, fully transactional and guaranteed delivered once and so forth. It gives us asynchronous processing, so now you can put things into a queue and you can have another processor that's out here taking things out of queue and doing things at a later time, maybe the next day, maybe a couple of hours later. You can have stored procedures automatically fire when something goes into the queue. And you can say how many stored procedures I should have as consumers for things coming out. So maybe the first 6 things into a queue cause 6 different consumers or 6 copies of consumers to go, and then they can all be taking things out of those queues as time goes by. So this is very powerful. And one of the capabilities with that is listening on HTTP. So we can have a web service, we can have SQL Server itself listening on HTTP without IIS in the box or in the picture at all. So SQL Server itself can listen to HTTP, certain stored procedures, certain users can call that. They could maybe put something into a queue that then gets processed by SQL Server Service Broker. The Database Tuning Advisor is the new name for the Index Tuning Wizard. It's a standalone program now. It can be run scripted. It knows about partitioning as well as indexing, has more information about indexed views and other things there. Multiple active result sets, or MARS, allows a single connection to actually have multiple result sets pending over that. In the past, when you asked for a certain result set, you had to process the whole result set, then ask your next question, or else maybe use cursors over that. Now you can have multiple result sets pending on the same connection. We have persisted computed columns. This is a relatively simple one. In the past, if you had a computed column, you could say my column 3 is really just column 1 and column 2 added together. And so don't bother to store it, but every time I ask you for it, get these two and then add it together. Well, what happens if it's a more complex operation? Like maybe there's a function that I get that this one is. So this function might take a while, and it could be a .NET function, a CLR function now. And so it might take me a few seconds to calculate. And so I'd rather just store it rather than have it be recalculated every time I need it. If it's deterministic, I can store it. And then I can create indexes on it and things like that. So now you can use the word persist after a computed column definition, and then it'll store it for you. Snapshot isolation level. SQL Server typically has used locking in order to provide concurrency. Okay. Well, snapshot isolation actually uses row-level versioning now. So if I have a version of a row and you change it, I'll make a copy of the old version and save it around. As long as you're working on this, someone else that comes along and he wants to read committed data, instead of waiting for you to finish, he could go out and read this value, which was committed at the time he started his transaction or started his statement. And that means that he has less blocking and less deadlocking that happens in there. This is something you actually have to enable at the database level because it does involve some extra overhead as far as storage there. But this is a great capability, and if those of you who are familiar with Oracle, you'll know that that is very similar to the way that Oracle does it, provides concurrency. So it gives you a much better mesh for moving from Oracle to SQL Server, or moving from some competitor's product to SQL Server. I've mentioned table partitioning a couple of times. Again, there's whole sessions just on this. But this allows a single table to be split into several partitions based on some value, perhaps by dates. So you can put all of January's orders into one table, or sales into one partition, all of February's and March's and April's. And when it comes time for you to bring in all of September's, let's say, maybe we bring September's into an empty table and we scrub it first. And then we build the appropriate indexes on it. What we can do is in a single metadata operation, take this other table and move it in as a partition to this big table. You can move millions of rows into a single table in a metadata operation in sub-second operations. As long as it's partitioned similarly, there's some requirements there. We do partition elimination by the query optimizer. If we know that your answers can only be in this partition, then we'll work with that. Each partition can be on a different file group if you want to do that. You can partition the indexes that go with it. You can also take last September's data if you don't need it anymore, and then again, a metadata-only operation. You can swap that out of this table and into a little standalone table, truncate it, archive it, whatever you want to do. But there's none of these batch deletes that you used to have to do or anything like that. The database tuning advisor can give you examples and give you recommendations on when that happens. So these are a lot of the new features that have to do with languages and programming. We've got the .NET framework now. You can write your stored procedures, your triggers, and your functions in any CLR language. And there's like 56 or 58 CLR languages out there now. So if you've got a developer who's very proficient in Pascal, maybe that's what he likes to write in. Maybe you have to write it in Ada. Maybe you have to write it in COBOL. Maybe you have to whatever. So all of those different languages, you could actually write your stored procedures in those. Not necessarily all appropriate, and it's not necessarily appropriate that you should do everything in this, because for data access, you probably still want to use T-SQL. But for computation, anything that's compute intensive, you might want to use a language that's very good at doing that type of computation. If you've already got all the code written for your middle tier, you might want to have your backend do something very similar. Quick question. Table partitioning is enterprise only. We have a full, so almost everything else There might be some differences. There are books online and on the web has a difference between the SKUs. Okay, we can create user-defined data types that we create columns out of. User-defined functions, user-defined aggregate functions. So if you always wish that we had another aggregate function other than just max, min, average, sum, standard deviations and variance, now you can go out and create your own aggregate functions. Transact SQL has a lot of new things too. We don't have time to go into all of them, but common table expressions gives you a great way to do hierarchical access. So if you've got managers and all of their reports and there's some sort of a tree structure, you can use a common table expression to do that all in a single statement, highly optimized, so that you don't have to use cursors, you don't have to use loops in order to do that. Pivot and unpivot turns columns into rows, rows into columns. Apply, accept, and intersect. So this is like union, except not exactly like union. We're either intersecting or doing everything except. We've got ranking functions, so you can actually put row numbers on down for every column in a row, things like that. The top can accept an expression. You can put tops in deletes and update statements, not just selects anymore. You can get an output, so you can say that I want to do an update, but I was wondering, what's that value? Once I add 10 to it, what's the output value from that? Well, you can output the results of an update or a delete. You can delete a row and get the values back of the thing that you deleted. We've got exception handling with try and catch. We've got new data types. There's a new XML data type. XML is defined within the database, and it's a type of a column, a variable, a parameter. We've got the new varchar max, var binary max. These are eventual replacements for text and image. So instead of saying varchar and being limited at 4,000 or 8,000 bytes, 4,000 characters for n varchar, now you can say var binary, varchar, or n varchar max, and just put the word max in there, and you can have up to 2 gigabytes in a single varchar. Stored very similarly to text and image, but you don't have to use the read text, the update text, the text pointer stuff. You can just use these as if it was any other varchar. Then there's XML, as I mentioned. XML is a data type of its own. Full XML XQuery support capabilities there. You can put indexes on XML. You can work with it with for XML, all kinds of great capabilities there. So 10 seconds doesn't do it anywhere near the justice. Yeah.
When you update, what happens to what will be the data type?
So
if you are having a text column.
Text and image are still there, and it won't automatically convert them over to varchar or varmax.
So it will be there.
Right.
Text.
Yes. So there, it is still there. Our deprecation, typically we announce deprecation, and then we support, and then we get rid of it eventually. Some other big engine features. So there are some things as far as database failure and redundancy. So failover clustering we've had for quite a while. We've done some more improvements, support for mount points, support for as many nodes as the underlying operating system supports. We even have failover clustering support in Standard Edition for a 2-node SQL Server failover cluster. Okay. Enhanced multi-instance support. As I mentioned, analysis services multi-instance. Full text is now multi-instance. So there's more instance support. We test up to 50 instances on the Enterprise Edition. Database mirroring. So this gives you a capability of mirroring a single database from one SQL Server to another. This is one of those things that we've announced that we'll give full support for this in about 6 months after SQL Server ships to make sure that we have enough validation. This is a high availability feature. We have a lot of customers that are using it, but I'm not going to tell you, go out there and bet your company on it right now. I want to see a few more companies that will work closely with us, and they'll bet their company so that when we say it's supported, all of you can bet your company or bet your data on it anyway. And so it is something that is still there, something that we're still very interested in pushing, but this allows you to mirror a single database between 2 servers, doesn't use failover clustering or the clustering support at all. Any databases or any user databases, any hardware, any network, any storage. So it's a great capability. But it's not an initial release. It is available if you want to talk to us. Database maintenance. So there's some great backup and restore enhancements. I'll mention a couple of them later. There's one of the best things with restore right now is, and database as a whole, is partial availability. If you've got multiple file groups in a single database, if one file under one of those file groups is not available because it's an external drive and you forgot to turn it on, what happens to your database? The whole database is suspect. Okay? SQL Server 2005, well, that file group is not available, but the rest of the database is, as long as it's not part of your primary file group. Okay? Primary file group, we need to have that fully available. If your primary file group is available, your database is available. Okay? You might not be able to get to some of that data in those other file groups, but at least you can get into your database. You can turn that on and then have it get in. Checksum integrity checks. This actually puts a checksum on every data page. So as we write a page on out to disk, we'll calculate a checksum for it, put it in there, write it on out. When we read it in, if we find out that the checksum's not the same as when we wrote it out, we know that there's a problem either with the I/O system or with the disk system. And some disks do lose bits. There's decay built into them or something like that, so make sure that you buy new ones every once in a while. I don't know what the thing is. Okay, but rather than getting SQL Server, or having SQL Server get the blame for that bit having decayed or not being the same as it was, we can say, hey, when we wrote it out, this is what it was. When we read it back in, it wasn't exactly the same. Okay? We have a dedicated admin connection. How many people in here are DBAs? Almost everybody? Probably. You've got one rogue process out there and it's pegging your system. And you don't know what it is, or you do know what it is, but you can't even get into the SQL Server to kill it. Okay? And so what do? Well, now you have to shut off your SQL Server instance and turn it back on again. And then it has to go through recovery and do everything that guy was doing that was pegging your system to start with. So it's probably going to peg your system a while longer while it undoes it. So now there's this dedicated admin connection. If you turn this on, we'll always reserve just enough space and enough connection stuff so that you'll be able to connect no matter what. You connect, only admins can do this. You connect with a certain option. You come in through this connection and you can do certain administrative type things, including find out who that is and kill that SPID if you need to. Okay? So that means that, okay, yeah, you still have to kill him, you still have to roll back what he did, but all the rest of your users haven't been affected or affected as much. Dynamic AWE means that you can adjust the amount of AWE memory that your system's running or working with while it's running without a restart. So SQL Server in the past has always grabbed as much AWE memory as you said right from the beginning, and if it couldn't get it, well, you only got what was in regular memory. Now it grabs AWE memory in a partial way, similar to the way it does with regular memory, and it can actually release it dynamically. So it doesn't cause a server restart if you ever want to change this. Fast recovery allows you into the databases sooner because you don't have to wait for the undo portion. Recovery, when you start up a database, we go through a redo phase and an undo phase. SQL Server 2000, you had to wait until the undo was done. SQL Server 2005, you only have to wait until the redo is done, and then you can be in there. We have a lot of index operations now, where you can get into the table, use the index to get to the table even while the index operation is going on. In the past, we'd sometimes lock the table, or at least you couldn't go through the index. You'd maybe have to do a table scan. Now we'll build that new index side by side, which we were doing before, but while you are updating the underlying table, we update the old index and the new one. When the new one's ready, we throw away the old one. So you never really lost performance going to that underlying table. Online restore, I mentioned that you can restore a file or a file group while the database is online. Parallel DBCC, more index operations are in parallel. We've got these great new things called dynamic management views. In the past, we had these things called virtual tables, like sysobjects and syslocks. It sort of gave you a view into SQL Server's internal structures. They looked like tables, but they weren't on the disk. what we did was we took this stuff out of here and we showed it to you as if it was a table. Now we've got somewhere on the order of 90 of these things that let you see all kinds of stuff and relevant stuff, not just, okay, what's there, but we interpret it, we show it to you in an appropriate way. The SQL Server Management Studio even has a whole set of reports. You bring up Management Studio off to the side is report, and down there are many different things. You can see a dashboard of what locks there are, what's going on your system, things like that. We also have triggers on DDL. So all of you who wanted to have a trigger every time somebody created a table or dropped a table or altered a table or added something to your system, now you can do that. So you can say every time anything changes on my system, send me a message, or prevent that person from doing that, even if of course they had to have permission to do that sort of thing to start with. Quick question?
For example, right now in SQL process, when you do the DBCC shrink file, if one of the tables has text columns, sometimes it won't shrink.
So one of the things that we do have with DBCC now is if it does have text or image, that we will shrink it. So, so it used to be that everything that wasn't text or image, so text and image used to have to stay in the same place it used to be, whereas everything else could shrink on down. Now we know about that and we can do that. It was a lot of extra work to do, that's why I didn't used to do that. Now, some people, how many people shrink your databases regularly? Is there any good reason why? A lot of people. So a lot of people shrink their databases only to have them grow again and move data around and things like that. Sometimes, okay, defragmentation is okay. How many people are shrinking their tempdb files? How many people are backing up their tempdb files? Okay, so a couple of people didn't raise their hands, the rest of you laughed. And so there are lots of best practices and things like that that we can talk about. But now, yes, we do shrink the text and image areas. So security. Again, there's whole sessions on each of these, but you might not go to the session just so that make sure that you've at least heard of these. All of the different permissions are grantable. It used to be that if you granted somebody the SA role, they had like about 30 permissions that they suddenly got. And if you wanted to give them one of these things, but not all the rest, you had to give them all of them. Now you can grant these things individually, one of them being use profiler. So you don't have to have all these permissions. Admin writes a separation of users and schemas. That's just, we've had users for a long time, but if a user ever disappeared, you'd have to drop all of his objects or reassign them. It's better to have an abstract thing called a schema that a user can own. Everything's backward compatible, so you can still use the old structure. Data encryption primitive, so you can actually use any of the Win32 encryption capabilities right inside SQL Server now. Full text search, a few things I'll mention later, but we can index the XML data type. So we can just have regular indexes on XML, and then we can do full text indexing as well. Several things with replication, a new replication monitor. One of the coolest things is you can put a little trace into your replication so that when it gets sent out there, we can find out what the latency was, and you can find out how far along they are. So it's sort of like a tracer bullet to see where you're going, a little trace that goes on into your replication stream. You can replicate DDL changes. If you're using replication in SQL Server 2000, if you're going to change or add a column to a table and you want replication to do that, you had to add the column through a replication stored procedure, and it would make sure it happened on the subscribers as well. Now what it'll do is it'll use those DDL triggers, and it'll say, hey, you altered this table, you added a column, and it'll be notified, and then it can add that column in the other places for you as well. New thing called peer-to-peer replication, which is a high availability alternative. Auto-tuning replication agents, you can publish from Oracle now. And then there's improved blob change tracking so that you don't have to send 2 gigs every time something changes, for example. Okay, so that was a very quick run-through of some of the somewhat major functions.